Welcome to Woodbridge Geometry Virtual Tutor. Today's lesson is on quadrilaterals and proving how they exist on a coordinate plane. So with all the examples we're going to have today, you're going to see different shapes on a coordinate plane, and we're going to be able to identify points that make it a specific quadrilateral and find what kind it is. So here's your first example. ABCD is a rhombus. What are the coordinates of vertex C? So this is a rhombus here, and you might remember from last class that a rhombus has all four sides that are the same. Similar to a square, but it's almost like a slanted square because we don't have 90-degree angles here in the rhombus. So what we need to do is figure out what this vertex is right here. So if you notice with parallelograms, a rhombus is a type of parallelogram, the opposite sides are congruent there. So what we can do to tackle this problem is if I know the distance between here and here, I can use that same distance to figure out the missing point there. Now this we could actually use slope for and follow that, because these are, this is a parallelogram, these are parallel lines, and parallel lines have the same slope, right? So what we can do is follow the same path. So from 0, 0 to 3, 4 here, from A to B, what was my slope? Well, I would have had to go up 3 spaces and over 4 to get there, right? Nope, that's wrong. We would have had to go up over 3, sorry about that. So up 4 and over 3 to get this one. So we're going to have to go ahead and follow that same path there. So we're going to go up 4, 1, 2, 3, 4, and over 1, 2, 3. And that would give me my final answer. So if we did that, we would have, this would be a 4, right? Because it would be on the same y-axis here. So this would be a 4. And then the x value, if we went over 3 spaces, we would do 5 plus 3, which is 8. So my answer is going to be C, 8, 4. All right, let's try another one. It says here in the drawing below, what must be the coordinates of D to show ABCD is a square? So I have to plot D somewhere. So if I were to look here, connect these dots, I know that my fourth point is going to have to be somewhere around here in order to make it a square, right? Because in a square, all sides are the same. So we can kind of do a little bit of what we did with the other one with a rhombus. But we also know if all sides are the same, if I can find the distance between here and here, I can copy that distance between here and here to figure out what this point would have to be. So to get from 1 to 7, you notice that these both have the same y value of 4, right? So what we're really doing is just counting our spaces to get from 1 to 7 here on the x-axis. We would have had to go over 6, right, to get there. So we can follow the same step, and to get from 1 from my y values, to get from 1 to whatever this point is right here. Oh, so we said the x was 6. Not 6, sorry. To get from 1 up here, how many spaces would I have to go? Well, if I went over 6 here, and I know that the diagonals are congruent as well, then I would go 6 spaces up as well, right? So 1 plus 6 is 7. And what would wind up happening is my x value would be the same because I'm still on the same vertical line right here. So 4, 7 would be my answer there. All right, so go ahead and try this one on your own. This is three vertices of a parallelogram. A, B, C, D have coordinates -1, 4, 3, 8, and 5, 0. What are the coordinates of the other first quadrant vertex? So you're going to have to figure out first and go ahead and plot these points to see what you're working with right now. If you remember the quadrants, 1, 2, 3, 4. Oh, these are actually plotted for you already. Sorry, I thought I had erased these before. So these are plotted for you already. So right now we have something like this. So I'm going to need, if it's a parallelogram, then that means we're going to need another point somewhere here in this first quadrant, right? Parallelograms have opposite sides that are congruent. So you would need to try to figure out what the next point would be. Now, it's not going to be somewhere like this because that's not going to make a quadrilateral, right? That's just going to be like a triangle. So you got to sort of figure out which one would make sense. So do what I had done before in the earlier examples. See if you can figure out either by slope or finding the distance, what would be that final point there in the first quadrant. So you might want to go ahead and pause the video here and work on it. And then when you unpause, I will display the answer. Okay, so your answer should have been D, 9, comma 4. So what you could have done was, if we know that opposite sides are congruent, we could have found the distance or the slope between this first point and this second point up here. So if you did that, we went up 4 and over 4, right? Rise over run. So we want to follow the same path there from this given point up 4 over 4. And that would have landed you right here, which is 9 comma 4. And that would be your answer. Okay, so let's keep going. It says quadrilateral TUVW has its vertices at -2, 4, 3, 3, 2, -2, and -3, -1. Classify. So this time we're going to have to plot these points and then determine, based on these points, what kind of shape do I have here. Okay, so let's go ahead and do that. -2, 4 would be right here. This is T. 3, 3, U. 2, -2, V. W is -3, -1. Okay, so if I were to connect these, I can definitely eliminate trapezoid. It's not a trapezoid, which means it's not an isosceles trapezoid. So we know for sure it has 4 sides, and it definitely looks to be opposite sides congruent, opposite sides for sure. So it looks like it's good to go for parallelogram and rectangle. What we can't guarantee is this a rhombus or is this a square? The way we can prove this for sure is with a ruler. If I can get my ruler on here. Nope. All right, well, if that's not working, what you want to do is figure out, you can do slope as well, or distance formula too. The easiest thing would be to get your ruler and measure the distance for each one of these sides to see, are they congruent. If they are all congruent, then we've got a square, and we've also got a rhombus, right? Well, we've got a rhombus for sure. A square if they make 90-degree angles. All right. So what we can do if we don't have a ruler is, let's go ahead and find the slope, right? Opposite sides would be congruent. They would have, if they're parallel, they have the same slope. So 1, 2, 3, 4, 5 over 1, right? So there's your slope of 5 over 1. Is this the same? 1, 2, 3, 4, 5 over 1. Yes, it is. Good. So we have a slope of 5, slope of 5. And let's try the slope from TU. We would be going down 1 and over 1, 2, 3, 4, 5. Negative 1/5. Down 1 over 1, 2, 3, 4, 5. 3, negative 1. It is right here. I just made that point too big. So it's down 1 over 5. So we definitely know for sure opposite sides. We're good here. We're good here. Right? And we also know that these slopes, negative 5 and 1/5, I'm sorry, positive 5 and negative 1/5, these are negative reciprocals. Do you remember learning about that? These are negative reciprocals because I have like a flip and switch, right? This is 5 over 1, negative 1 over 5. They're opposite signs and their fractions are flipped. So those lines are actually perpendicular to one another. So that means if they're perpendicular, guess what they're going to form? 90-degree angles. So if they form 90-degree angles, then for sure we've got a square. And a square is also considered a rhombus. You remember your quadrilateral tree? So if it's a square, it's got to be a rhombus, which means it's got to be a rectangle, which means it's got to be a parallelogram. So all of those would actually be your answer for sure. All right, let's see if you can do this one. Try to plot those points and then classify what kind of shape you have. If you have a trapezoid, isosceles trapezoid, rectangle, rhombus, square, or parallelogram.
Attention all staff, Miss Odell, student ability. Please go rejoin number 17. Your order is here. Miss Odell.
Okay, so if you tried it, you should have gotten rectangle and parallelogram. Remember, if it is a rectangle, it is a parallelogram because it goes underneath in the quadrilateral tree. All right, we've got parallelogram. And underneath it, a type would be a rectangle. So if you go from the bottom up, this is yes and yes. We've got to have both of these. So what you should have done was you could have found the distance between each of the opposite sides. You would have found that they are congruent there. You would have also found that the slopes were negative reciprocals of each other, so they formed 90-degree angles there. They did. Okay. All right, and that is it for this lesson. Remember, if you're proving it's a quadrilateral, you can do a lot of different things with slope and distance just to make sure that opposite sides are congruent, forming 90-degree angles. Um, you can always use distance formula. There's quicker ways to go about it with slope and even bisecting, finding midpoints and things like that. So you've got to use your quadrilateral properties in order to prove that these are what they are on the coordinate plane.